Morning, everybody. Welcome back. Still letting a few people in. I don't see Bonnie. Bonnie? No, Bonnie's not there yet. Well, she'll be here shortly. She didn't tell me that she wasn't going to be here today. Okay, crazy week last week, and some are still dealing with either getting back in their homes. I've actually had a couple students say they've lost their homes, so it's a frustrating, sad, sickening time for some. Letting a couple of the people in. Oh, here comes Bonnie. Morning, Bonnie.
Good morning.
So those who just came in, I was just saying that, this last week, pretty whack. And sorry for those of us, well, I didn't get displaced. I live in Sebastopol. So those of you that got displaced and had to deal with more extreme circumstances than what I had to deal with. I had, well, most everybody had to have, the air quality was just awful in some days, and then other days better. So those of you that are dealing with other stuff beyond, if you're here today and you have been displaced and you're still dealing with trying to figure out housing, for instance, let me know privately and I'll work with you, let you know what I can do on my end. If you're here, you got internet somehow, but you might be out of your home still. Not everybody's back in their homes. And if you lost a home, let me know that too. And whatever I can do to help. This class, fortunately, didn't have, you don't have anything looming in terms of an exam, even a group quiz, it's not there. My other classes do, or did, have. Your assignment schedule, I think I sent you guys out it's called a revised assignment schedule over the weekend. Okay, you're shaking your head, that's good. I'm gonna show you what that looks like to make sure we're on the same page. I had to make some adjustments on a couple of classes, and I can't remember if yours was one of them. So, okay, I'll open this up. Farbod, can you see what I'm seeing here? Okay. So hopefully you all have had a chance to open up the document. If you didn't get this for some weird reason, then let me know, and I'll get it to you. Anyway, this is last week's with the dates, Tuesday, Thursday for you guys. The JC made a decision, which I feel like they did it right. At first I was, well, why are they canceling Thursday and Friday or Wednesday and Thursday? Why are they doing that so soon? Well, it turned out that they were spot on, in my opinion. The air quality for a big reason. So we didn't have class. We lost 2 days. I had to go back for all the classes and say, okay, how do we accommodate that? It was a easy thing for your class because I think I had budgeted in review days at the end. Yeah, just like some of the other classes. I think I had 2 review days at the end. Well, you don't have those now. I just shifted everything down a week. And So that's not a big deal because my classes face-to-face, when we used to be face-to-face, they never had a review day before the final. And if they did, it was not very long. It was a really short period of time. So your last day of class before finals will be your group quiz. And then you've got your final. So that's this is like your practice exam. And this will cover number 4 covers all the material that you hadn't been tested on. So it looks like these topics in here in particular, and which is 1.9 all the way to 9.5. We're not there yet. And as you can see, I've got daily quizzes sort of planned. Today there will be one. It'll be on complex numbers, which I'm going to go over briefly, remind you how that worked, and get you thinking about that. And then today we'll do quadratics, which is parabolas. It should be familiar compared to what your previous course was before this. So that's nothing new. Just need to be reminded how to do them. So we're in good shape, I felt, for this class, Math 25. In terms of the math class itself. In terms of good shape beyond that, everybody's got family stuff, just life stuff going on. And so we're doing the best we can. You guys took this class under certain circumstances, knowing that it's going to be a challenge. And then, now we're living in, I guess every year we're going to have fires to deal with. Every year. I mean, just expect that. And if it doesn't happen, well, then happy days. But that's what I would say is expect it every year. Expect that it's not finished. Expect the worst case scenario. And worst meaning in terms of the math class, if we have to adjust anything else because there's something that happens, I'll figure it out for you. I'll figure it out. So you're not having to stress. I'll do the stressing. I'll take that on. So 2.2, and then you will have a little quiz number 5, it looks like today. All right, let's, Bonnie, any comments, announcements on your end?
Nothing on my end.
Okay, anybody show up this morning?
Yes, I had a student.
Good, sounds good. And did you do any review? Anything on the complex numbers?
Yeah, it was questions on the complex number homework.
Okay. And to remind about the homework, there still seems to be, maybe not in this class, but other classes, the homework is due on the day of the exam. You should be working on your homework so that when you see Bonnie, for instance, hey, I have questions. 2.2, I'm going to go over that. You should be working on that tonight and tomorrow so that on Thursday when you meet back and you see Bonnie or you see me after class, you might have some questions. But you don't submit it to me until this little window of time. And let me even go over that with you right now. I'm going to show you my Canvas page for you guys. Because I had to go through and adjust all the times and the dates that the exam will be released, for instance, or the homework window of time. That took me a long time to set up initially, and then it took me a long time to make the adjustments last week. So it's all technology on my end. So let me, what do I want to do? I want to do this. Do this one. Math 25, okay. Can you guys, Farbod, can you see this page? It says homework here. Okay, good. Now you can't see, but I'm looking at it. You can't, unless you have the copy of your assignment schedule in front of you. I'm seeing the assignment schedule. You can't see it on my screen. You can only see the Google page. Anyway, I'm looking here, for instance, your next exam, I pushed it into October 27th. That's your new date on the exam number 2. And reminder, exam days, you don't show up for this class. You don't do that. You're working in theory on your exam, although you have 24 hours to be doing that. So don't show up on exam days at all, period. Anyway, October 27th. Now, if I've done this right, exam number 2, yeah, there it is. I can see it right here. So it's due at 10:30, which is the end of our class, October 27th. And I will release it. The machine's ready to release it on the day before at 10:30. So you have 24 hours to take a look, just like your first test. Take a look, work it out. You don't send me any of your work on the exams. So don't send me anything. You're just submitting the answers, pressing the buttons. What I want submitted would be homework and group quiz stuff. That's what I want. So the homework up here, number 2, I should have set it up. Yep, I did it right. So homework is due no later than when the exam shuts down. If you don't submit it to me and you say, Jeff, I've had internet issues. Yeah, no, please don't make that excuse. I mean, you got plenty of time to get it to me early to work through the internet. For instance, October 24th. That's 3 days right there. I've given you 3 days to get it to me. I'll say there's an exception or two, maybe. Well, gosh, this is like the end of the month, but still the end of the month. If you are someone's displaced / lost their home, then let me know and I'll work with you. If you're in that situation, let me know. Okay, but the rest of us, you'll have a window of time. So I'm looking back here on my assignment schedule again. That gives us, what is it, 2.5 weeks will be your quiz number 2 in 3 weeks from now. On a Tuesday, the 27th is exam number 2. Now, if I go to group quiz, it should be 2 days earlier. Let's see if I did that right. Okay, group quiz number 2 is the 22nd. It is, so it's on the Thursday before the Tuesday. So that looks like I set that up correctly. And then notice I'm giving you a little extra time to polish it up, 12 o'clock. So the group quiz, you're going to get it the day before. You can work on it anytime you want. It might be a good idea. You could actually finish it before the day that we meet. You could finish it and even submit it to me, your results, before you meet with anybody else. You could do that. But I'm giving everybody an extra hour and a half on the group quiz day if you need it. But after 12 o'clock, it shuts down. So don't wait and say, Jeff, it shut down on me. I was just polishing things up, and now it's 1 o'clock. And what do I do? Can I send it to your email? Don't do that, please. I'm giving you enough time to do it. Okay, so at least for group quiz 2, homework 2, exam 2, looks like I've set it up in the machine. Now it's just up to the machine to send it to you correctly. All right, let me get out of this here. Okay, so before I show you a couple examples of complex numbers where we left off, any general questions for me? Okay, none. Okay, here we go. Oh, hey, Bonnie, after class, you stick around, or when they start their little quiz, stick around. I've got something I want to share with you.
Sounds good.
Review. Shoot, I'm out of scratch paper. Can you believe that? Out of scratch paper. I can do it back here. Complex numbers, complex. Now we know that square root of -1 is I. And then if you square both sides here, you got -1 is equal to I squared. If you have the, see, example 1, if you have the square root of -16 plus, I don't know, negative the square root of 9. Okay, this one here has the I, this one does not. So this one here is 4I, and this one here is a plus a -3 or -3. And there is an A plus BI form as well. So you have to move these positionally wise. You put the -3 first and then the 4I second. So that when if I asked you what's your A equal and what your B equals, then A is negative and the 3, -3, and this is +4. Let's see if I subtract, add or subtract. If I subtract two complex numbers, let's say I go 3 minus 2I, and I subtract 1 minus I, then we distribute the negative. So you get 3 subtract 2I, subtract 1 plus I, and you collect like terms. Collect like terms. Okay, so that's 2. Subtract I, if I haven't made a careless arithmetic mistake. And you box your answers if you needed to, and you say A is equal to 2 and B equals -1. Okay, number 3. Let's see. Multiply. Let's take these same two numbers and multiply. So they go 3 minus 2I times 1 minus I. And think FOIL. So pretend the I part of it, the imaginary part of the number, is a variable. So 3 times 1 is 3. 3 times -I is -3I. So just pretend it's a variable like x. That would be -3x. And this is -2I. And positive, two negatives make a positive, and a 2. And if these were variables like x times x is x squared. So I times I is I squared. Let's see, that would be 3. These are like terms, minus 5I, plus 2. And now we know that I squared right here is the same as -1. Remember up here, I squared is -1. Okay, that's -2. 3 subtract 2 is 1, subtract 5I, and that's in the A plus BI form again. And then finally, you got division. Now I'm going to do 2 division problems. Number 4, I'll go, let's say 2 minus 3I all over, let's say 2I. And then I'll do 5 here. 2 minus 3I all over 1 plus I. All right, so conjugate, the word conjugate comes into play. Conjugate for division. Now, if I look at the binomial, the conjugate, hopefully that makes sense that you're changing the sign somewhere. It's only the B that changes the sign, only the B part. So I'm going to look at this as 1 minus I. Don't change the 1. Don't make that -1 minus I, it won't work. So what I want to do is I want to take this as well as the top and go 1 minus I. So only the B changes. Isn't this the B? This one over here, it's a monomial. See, this is a binomial, it's a monomial. So the way I think I taught you is I say, hey, if you think conjugate, it'll work. It'll work. There's another way, actually, there's two other ways, or multiple ways. There's infinitely many number of ways to handle the denominator on this one on a monomial. There really is only one way to handle the denominator on a binomial. Really only, it's called the conjugate, which they look the same, opposite signs in the B part. Here, if I want to think conjugate, all you do is go negative 2i. It'll work. It'll work. It's not the only way, but that is the only way. Okay, so number 5, if I continue, the top is a mess. I mean, initially it's a mess. Let's see, FOIL, that would be 2 minus 2i, subtract 3i, and plus 3i squared. The bottom is nice. It's a difference of squares is what it is. 1 times 1 is 1, minus I, plus I. On the difference of squares, the middle terms always go away. And then, let's see, minus I squared. Top, collect like terms. So let's see, that's minus 5i plus 2 plus 3 times negative 1. The denominator, these go away. And you're left with 1 subtract negative 1. Negative 3 plus 2, negative 1. That's first, and then subtract 5i, a plus bi, and then here it's 2. And you might think that's the answer. In the back of the book, it's probably not. In the back of the book, they probably write it as an a plus bi, which you bust up the fractions. So then bust this up as negative 1/2, that's your a, minus 5/2, that's your b, and then I. That's probably the back of the book, and that's probably what you're going to find on the multiple choice version of the test, probably. If for some reason, because I get your questions from a test bank, it may not be that, it may be this. For some reason, it might. So you pick the best answer. Pick the best answer. Okay, now this one. So this one here I'm going to distribute. So that's minus 4i and then plus 6i squared. Down here is negative 4i squared. Okay, now, easy to make a careless mistake. You think the I squareds will cancel, or you might go, hey, the 4s will cancel. It looks tempting. Don't do it. It's an easy mistake. What you want to do is simplify the I squareds, and so you got minus 4i. I squared is negative 1, so that's minus 6 over negative 4 times negative 1. Okay, we're back to negative 6, subtract 4i all over negative 4 times 4. And then again, you go, and we'll reduce probably fractions, minus 4 over 4i. So then you get what, negative 3/2? Minus 1i, or just I. Okay, so there's a quick review, and hopefully your homework that you'd been working on was not a challenge. It wasn't time consuming. Shouldn't be time consuming. Now, in 2.2, we're going to take a look at what they call quadratics. So it's a degree 2. And on occasions, you might have a degree 2 polynomial. You might say, hey, here's a solve. You might hear a solve, and it's a quadratic, so x squared minus 2x. It might be minus 10 or something like that. Minus 10 equals 0. And if you put this in the quadratic formula, it may turn out that your radicand at the end, your radicand is negative, and therefore it's an imaginary, actually 2, because they come in little pairs. Remember, it's plus or minus the square root, quadratic formula. 2 answers that are imaginary.
Hey, Jeff?
Yes.
For number 4, when it's a monomial, like 4i, or no, what was it, 2i in the original equation, do you have to multiply by a conjugate? Could you just multiply the denominator by 2i just to cancel out?
So Devin's asking a question, are there any other ways to take care of a monomial? And yes, I said that there are multiple ways. Matter of fact, there's infinitely many ways. Infinitely.
Mm-hmm.
There's only one way over here.
Yeah.
Infinitely many. So you're giving me one of the infinitely many's. Could he multiply top and bottom by just 2i, not negative 2i, and get rid of the I? The whole point is get rid of the I in the denominator.
Yeah.
So the answer is yes, 2i would have worked.
Oh, okay.
What else could have worked? Anybody? What else could have worked? To get rid of the I, what else could you have multiplied top and bottom by?
I.
Right. Okay, Devin, you got it. Okay, anybody else? Give me another suggestion. Besides I, besides 2i, besides negative I. Thought I heard somebody.
4i.
Right. Okay, so Devin, you're on a roll. You're getting it. Maybe nobody else is getting the idea. So nobody else is getting the idea because they're memorizing conjugates, which is fine. The conjugate always works. But yeah, Devin, you're spot on. There's you got I, you got 2i, you got 4i, you got pi I. Yeah, you got lots of, you got to have the I in there. That's the key. Got to have the I. But this one here has to have a conjugate. Because if you don't have the conjugate, you're not going to make the I go away. You won't. Oh, okay. You don't believe me. We got time. I can show you. You don't believe me. Okay, last problem. I'll pretend you don't believe me. 2 subtract. Even if I get one person that says, oh, that's interesting. He's going to, because I thought you could do anything down here. Okay, so how about this? Oh, 1 plus I. Let's just do that because it looks, or let's make them both negative. Yeah, that's most of you would probably do that, make that, thinking that'll work. Let's make them both negative. Okay, so negative 1 minus I. Let's make them both negative. Okay, so if I FOIL this, you get negative 2 minus 2i plus 3i, and then plus 3i squared. I don't care about the numerator. Numerator, i's are fine in the numerator. Well, the I squared is going to go away, but see, if you combine like terms, I in the numerator, no problem. I just don't want an I in the denominator. So now I'm going to go negative 1, FOIL this. There's negative I. There's negative I, and there's negative I squared. So here's the problem in the denominator. That isn't a problem because that'll go away, but that's a problem. You're back to having this I thing in the denominator. The point of this is trying to create another imaginary number so you can write an a plus bi form. Make the I in the denominator go away. There's only one choice for a binomial, but infinitely, which Devin gave me 3, and I gave you 1. That's only 4 out of infinitely many choices for a monomial. There, that monomial. Okay. Okay, let's take a look at 2 points, whatever that was. 2.2. Okay, the graph of a quadratic function is called a parabola. Parabola. And for this class, there's 2 forms. We call them standard forms. 2 ways of looking at a parabola. Your 155, if you took the 155 from SRJC a year plus ago, and you waited for another math class for a year and a half, or if you took our 156 or 154, I think those 2 classes before this. And if you didn't take either one of those, then it would have been your high school advanced algebra class, or you came from another university, college, and took an intermediate algebra. Somewhere you had to have seen it. Had to have, at some stage in your life. You would have had a function that might have looked like this, and you're asked to graph this. SRJC, our courses for, gosh, I've been teaching here for almost 30 years. Yeah, right when I first came in, we were using the old models of the Texas Instruments graphing calculators were just starting. So I've used a graphing calculator for almost 30 years. So we would have figured out how to graph this thing instead of by hand using the technology. So this is one version of it, but you still gotta, you gotta figure out what the vertex is, which I'm gonna show you a couple different ways. And the other form of the, as an example, might have looked like this. So every time I've taught, or even as a student, when I took my intermediate algebra here at SRJC 100 years ago. And this was a common form which allowed me as a student to identify the vertex without a graphing calculator, because when I took it, there was no graphing calculator. When I took my algebra class, there was algebra. We had calculators. It wasn't like we didn't have calculators. We had those, we just didn't have the technology that you guys have now. So in here, these are called the H's and the K's, HK form. That's what I was showing you over here earlier in this other page. There's an HK form, which easily identifies the vertex. The vertex is called H and K. The vertex is H comma K. Those are two numbers. Well, whatever the number is here, here's the thing that gets tricky. Whatever the number and the sign is here, you have to change the sign and keep the sign. See, K for keep, that's as a student, I was getting that mixed up as a student. Hold it, you change the sign on one and not the other? I don't get it. Until I got it, I had to memorize something. Change it, okay, what's a change? There's an H in the word change. C-H-A-N, change, keep. Change, keep. The vertex will be -5, 7, guaranteed. It will. Change, keep. So you go, but Jeff, it said H. It should be negative. Yeah, it doesn't work that way. I know, it's confusing to me as well. So just think, change, 1, keep. And we'll come back and graph these again and show you that what I'm doing is, it works, it's correct. But gosh, if you just graph this, there is a way to find the vertex no matter what anyway. It's called the minimum and maximum. Did I go over that with you guys? That button? Have I done that? In intervals for which it's increasing, decreasing. Gosh, I can't. I think we did, chapter 1, right? Okay. Fine. You're gonna make me do this. Yes, you've done it. Okay, so I'm answering. You have done it. You've done those. So we'll just review and just use the button on the calculator, and you'll find out the vertex or the vertices are in fact those. All right. So now, sorry, I'm flipping back and forth. The other version looks like this. Okay, it looks like this. And in your advanced algebra class, if you didn't use your graphing calculator, you had to figure out the vertex by hand. By hand. Some of your instructors will do that. And then we'll check with the calculator. So this is by hand. This is how you did it. Okay, there's your X part. What's the X represent? Well, it's almost like H. H is equal to -b all over 2a. Okay, that's another way of writing the X component of the vertex, so we call it H. So if I look over here, H equals, oh, that's your A, that's your B, that's your C, like in your quadratic formula. So H is the opposite of 4 all over 2 times A is 2. So it looks like it's what, -1. So the vertex right here is -1 comma something, comma something, comma I don't know. So here's how you find it algebraically. You take your h and you plug it in. You take the number -1 and you plug it in up here, and it will find a number, and that's your k. You want to find what f of, well, f of h is equal to k. When that's x is, when x is h, f of x is y. When x is h, y is k. When x is h, y is k. Oh, okay. Well, plug in the -1 up here. So you go f of what, -1 equals to -1 squared plus 4 -1 subtract 3. Square negative is positive, so that's 2 minus 4 minus 3, -7 minus 5. So if I haven't made a careless mistake, it's -1 comma -5, and there's a way of checking this, and that's what I'll show you right now. Let's do it right now. So in your class, you go y equals, and get rid of the garbage up here by hitting clear. Okay, now I'm going to type in this. I always do zoom standard because that'll give me a 10 by 10 screen. Zoom 6, zoom standard. It's probably goes up. Okay, we might have talked about this before. I knew ahead of time, before I even graphed it, to make sure that I typed it in right. Before I even graphed it right here, I knew as a parabola was going to go up. It had to. And if it went down, I typed something wrong. The leading coefficient, see, it's got to be in descending order of power. Since the 2 is positive, the parabola goes up. Parabola goes up if the a is positive, parabola goes up. If the a is negative, the parabola goes down. So I knew it was going to be a parabola that goes up. And that vertex, okay, that's in quadrant number 3. Well, that point is in quadrant number 3. Oh, and that kind of looks like -1, -5. Kind of looks like it. To verify it, to make sure, in fact, I didn't make a mistake here, like a little algebra. Gosh, I could have said -7 plus 2 is -6 or something like that. I could have put -6. Wrong. It would look like it's in quadrant 3, but that's the wrong number. You're going to go second, calc. Now, minimum or maximum, minimums are valleys, maximums are mountains. Our picture was a valley. That's the way I'm looking at it. So it's a minimum. And the way I taught you guys is to answer the question, the left bound, answer the question by typing in a number to the left of here. Here's where I'm trying to find right there. To the left of the purple dot. I see the cursor. I'm going to ignore the cursor. I'm going to answer that question by typing in the number, some number to the left of this, like over here, way over here, like -8. All right, so -8. When x is -8, I get a flag over there, and that's a bound. It's not going to look any farther than that on my screen. The calculator is not going to look any farther. In the right bound, again, I'm ignoring wherever the cursor is. I don't even bother with the cursor. Right bound, I'm going to pick something over here, like 8. So it's going to look between the two flags, and it's going to find the lowest minimum, the lowest y, which should be the purple dot. I hit enter to say yes for guess, and I saw the cursors right there. I'll erase the purple dot, and sure enough, there's your -1, -5. So I know from the calculator, at least it's verifying that I did the algebra right. Okay, this is like a review. Okay, first let's remember that the difference between relative and absolute, which you guys have worked on about 3 weeks ago, the absolute is the largest, highest, biggest, whatever, farthest y value. And it's always the y value found on the graph. And same with the minimum. Now, remember, it's only the y value, not the ordered pair it's found. Okay, so on the group quiz, I'm going to be very detailed. I'm going to look to see if I ask for the relative or the absolute minimum, if you said on the last problem like this, absolute minimum equals -5, I'm going to mark it wrong because you did not identify which variable it represents. I'll mark it wrong. So you can't, if you do that, it's going to be wrong. Y equals -5 would be the correct written way. Now, on the test, you're trying to pick the best answer. The author, test bank, may just say -5. He might. Okay, well, that's the way it is. But on my group quiz, I'm very picky about what that is. Also, it's not an ordered pair, not an ordered pair. So on the group quiz, if you go -1, -5, well, that's the ordered pair where the absolute minimum is, but what is it? Which number is it? You're just giving me an ordered pair. Definitely wrong, definitely wrong. So just be careful, and if you're not clear about what I just said, see me outside of class or see Bonnie. Okay, now, relative is where there's turns. Where's a turn? So if I look back on this picture right here, is there a relative minimum? Well, sure, it's right here. Here's an absolute minimum. Well, sure, it's right there. It's the same thing right there. Is there an absolute maximum? I say, even if it's infinity. Now, some authors will say, yeah, it's got to be some number. If it's infinity, we discount that. I say there is, and it's y equals infinity. So for my class, y equals infinity is the right answer. But is there a relative maximum? No, there's no turn. There's no turn. So this one here, that was the you know, I think I just flipped pages. I think my pages got stuck. I apologize for that. It's like I skipped pages, and I apologize. See, here's where I was, and then I flipped the page, which I thought it was a page, and it got stuck. So I apologize for that. It's not a problem. I just went ahead and said, hey, what's the minimum max? So I think this one here, might as well go ahead and do that since I'm on this page. Minimum, maximum, what would they be? So relative, and absolute minimum. Okay, now, because infinity is this obscure thing we don't know, you might consider the little squiggly. If you don't, I'm not going to make a big deal. If you wrote equals, I'm not going to make a big deal. Here's where I have a problem with. Some students will say, I'll say, what's pi? And they say, pi is, here's the big thing, that's a bad word. Pi is 3.1428. No, pi is not equal to 3.1428. It's not. It's a round. You have to use a round. So the maximum value is pretty darn close, or is around infinity. So if you left it equal, though, on this infinity thing, I'm not going to make a big deal. Squiggle is probably the better answer. And you'd say no, relative max. All right, now on this one, the vertex, might as well go ahead and finish up this page a little bit. I'm jumping around today and I apologize. My pages got stuck. Apologize. All right, let's see, go back. Change the sign, keep the sign. Change the sign, keep. What about that, Jeff? Well, don't worry about it right now. Change the sign, keep the sign. Change the sign, keep the sign. Okay, well, what if I don't want to do that? Well, then go ahead and graph it and check it out for yourself in your calculator. You don't want to do it the way I just showed you. No big deal. No big deal. You can always use your calculator because you'll have access to your calculator, your notes, and your book on the exam. So clear that out, type it in. I've had some students, I think specifically yesterday, it was in a stat class, and she pressed this instead of this, and she got something called syntax error, and she couldn't figure out what the problem was. I said, well, what sign did you use? Oh, that one. No, that's a subtraction. This goes between two things. If you've got a negative, you have to use that one. I think all of you knew that. So press that first, and then you go to parentheses, subtract. Now this one here is a subtraction. So that would be this key right here. See, there's a little difference. It's a longer one. That's a higher, shorter one. 3 parentheses squared, and then plus 8. Zoom standard, sure, okay. Hey, it goes down. I knew that because that negative right there, negative A, negative 2, made it go down. I knew that. Right, so gosh, that means even without a calculator, if I knew that there was the vertex and it went down, I knew that was the vertex and it went down like this. I made a mistake here. I'm catching it right now after 5 minutes. I said it right. I didn't do what I said. And this is good because then that way I can check it. Look at my vertex is in quadrant number 1. And I wrote something that's a mistake. Change the sign, keep the sign. That should be a positive. My mistake. So it actually shows you that I could make a mistake on the algebra, but I could check myself on the calculator and try to figure out what went wrong. So it's a good thing that I make mistakes so you can learn from me. So 3, 8, that's in quadrant number 1. Sure, that looks like 3, 8. Sure it does. And so you can say relative max, min, let's do the min. Relative min, none. Absolute min, well, remember it's the y value, so it goes forever this way. Negative infinity. Okay, squiggle, fine. Absolute and relative max is y equals 8. And since I'm still on this page, I might as well wrap this page up. Domain and range is something else that you guys dealt with probably first or second week of this course. So the domain would be all real numbers unless there's fractions, roots, or logs, or there's something else, but your course won't get into it. So fractions, roots, or logs. There's no fractions, roots, or logs for either one of these, so guaranteed it's all real numbers. So the domain right here, D for the domain, would be all real numbers, D for the domain, all real numbers. Now the range, capital R for the range, is low to high. So on this one, the low is negative infinity and the high is 8. Infinity never gets a bracket. So parentheses negative infinity up to 8, and I put a bracket on it because I actually get it. So the range would be negative infinity up to the highest, and I got that in the wrong place. Caught it this time. Negative infinity up to 8 bracket. And on the previous one, I have to go back to the vertex or even the minimum. Okay, that's negative 5. So I know this one here went up. And there's your vertex right there, right there is your vertex. And the vertex of the y value happened to be -5, right there, -5. Oh, that's the lowest. So -5 to infinity. This one should be -5 up to infinity. And this one here should be a bracket because you actually get it. That's your range. So some questions will be on your homework that will deal probably with relative mins and maxes, absolutes as well, and then domain and range. And if not on your homework, then I'll definitely be able to ask that on the exam and or the group quiz. Okay, I'm going to go back to the pages that I skipped over and see if there's anything that I need to address. Okay, all this is just another one. All you have to do is use your calculator if you wanted to, and I'm fine with that. If you use the algebra, then you should probably rearrange this so it's in descending order of power, so you make sure you get the correct A and the correct B and the correct C. Okay, this is the other form that I'd already been working with. And as you can see, this one here was 3,8, which is, I fixed that on the next page. I had 3,8. I made that mistake. 3,8. Change the sign, keep the sign. Oh, here it is. H is always the opposite of the sign value, and K is keep the sign. Oh, I did those already. Oh, symmetry. You guys dealt with symmetry at the beginning of the semester as well. You had, let's see, you had symmetry with respect to the x-axis, symmetry with respect to the y-axis. All this stuff, by the way, will be in your final exam because you've already gone over it. Symmetry with respect to the origin. Odd and even functions as well. You dealt with odd and even functions. Now, with a parabola, I think you get the idea that it's symmetric. You cut it right down the middle, which is where the vertex is. It's a mirror image, no matter which way you look at it. So there's something called the line of symmetry, which goes right through the vertex. And the line is always vertical. We want the equation of the vertical line. That's what I want. The line of symmetry is the equation of the vertical line. So the line or axis of symmetry is always a vertical line. And it's always x equals right there. X equals the number. So if you think about where it goes through, let's say the vertex on this one here. And I know that this is going to go up. And I know this is quadrant number 2. Quadrant number 2. So -5, 7, like somewhere over there. And it's going to go up. So the line of symmetry is right there. That's a vertical line. And that goes right through this ordered pair. And there's your x value. So the line of symmetry would be x equals -5. The line of symmetry on this one would be x equals 1, guaranteed. Okay, I gotta go back to the vertex on this one. V for vertex, I think it was 3,8. I'll check on the previous page. I think the vertex was 3,8. Nope, wrong. Good thing I checked. The vertex is -1,5. Okay, there it is, -1,5. Well, on this one, that was the wrong vertex. The vertex is -1,5. Oh, so this one here, the line of symmetry is going to be x equals -1 for sure. Okay, all right. Now, The last thing, you'll have a couple problems for homework, word problems too. The last thing is dealing with the word problems. These examples that I have here are very easily found, and probably will be found in a different version of it, easily found in your calculus 1A class, easily. There's a whole chapter section on what's called optimization, and Bonnie can attest to that too. You want to optimize, you want to maximize something, you want to minimize something. So, so you're getting like a little baby introduction of that. And we're going to approach it differently than the 1A class. 1A uses different techniques. I think these problems could use a picture. Helpful for me if I saw a picture, and then see what's going on. Okay, you got 80 yards of fencing, okay, and you want to enclose a rectangular region, and you want to use up all the fencing. You don't want to have any left over, and you don't want to be short. So you're going to use up all 80 yards. That doesn't say it in there, but that's the implication. Find the dimensions of the rectangle that maximize, that means gives you the biggest area. So, okay, here's your rectangular region right there. And you want 80 yards of fencing. So let's see, they want to know what the dimensions are. Don't we go like maybe X is the short and Y is the long, maybe, or length and width? Let's do that. X equals the width. And Y equals the length. So if I know, and all these problems, all the ones that you're going to be doing, I don't think there's any exceptions, will have two equations. You'll have two equations. And then the idea will be take one of the equations and substitute it into the other one. I'll say it again. You have two equations. That's the way I'm going to set these up. Two equations. Take one of them and solve for one of the variables. Doesn't matter really which one. Solve one of the variables and then plug it into the other, and then we're going to do something with it. So one of the equations will come from using up all the fencing. So if you remember, gosh, fencing perimeters add up all the sides. So perimeter is equal to 2 X's and 2 L's, or 2 Y's, 2 Y's. And we know what the perimeter's got to be. It's got to be 80. And that's 2 X's and 2 Y's. And then there's something about the area. So you want to maximize the area. Maximize area. This is your target. So this is an important one. I'm going to use this one and substitute this one over here eventually, because I want to answer the question about maximizing. Now, maximizing sounds like it's a parabola. Sounds like you want a parabola that goes this way, maximum, which is true. If you want to minimize something, your parabola ought to go this way, up and down like this. Okay, how do you find the area of any? Oh, that's easy. Area of a rectangle, area equals X times Y. So you have two equations and two unknowns. You guys learned in your previous algebra class, and actually your baby algebra, your beginning algebra, deals with what's called substitution method and elimination method. It does. You just need to be reminded about how to do it. So I'm going to solve, pick one of these variables to get by itself, and then plug it in over here, so then all you have is one variable to graph. I'm going to choose to solve for Y, so that when I plug it in over here, both of these will be X's. I'll solve for Y, and so what's left over here is something with X's, and I'll plug it over there. So solve for Y, solve for Y. That means you got 80 subtract 2X is equal to 2Y. So then you got 80 subtract 2X divided by 2, which is equal to Y. Oh, but 2 goes into both of these pieces, so that's 40 minus X. is equal to y. X. I said X, but I wrote Y. That was weird. Right, now, since Y is equal to that, this is where I'm going to put Y right there. 40 minus X is going to go right here. Area equals X times 40 minus X. It's the second time I did that. Oh my. And now you'll graph this. That's what my suggestion is, graph it. Jeff, what do you mean graph it? Well, pretend this is a function. So this is like an area function. A of X is equal to, well, you could distribute, but you don't have to. You could graph it exactly that, and the calculator will know. Let's leave it that way. Think about this too. If I distributed the X, wouldn't there be a negative X squared? So it makes the parabola go down like this. If I distribute that, that'll be negative X squared. So that's a good thing because the parabola is going the correct direction. So I'll just graph this thing. Y equals, clear that out, I'll graph this. Okay, zoom standard. Oh, I got a little diddly thing. That's not helpful. But I know there's a parabola somewhere. So this is where you have to use your calculator any way that you know how to adjust your screen so you could see like the vertex. That's what you want to see, the vertex. Here's another idea. If you found the vertex algebraically, you don't even have to use your calculator. You found the vertex, then you've got your answer sitting there. The vertex is the answer. That's somehow. I'm going to find it with my calculator though. I think I'm going to go higher because it looks like I needed to. I'll go 100. See what I get. Oh, I'm getting closer. I'll go higher. Let's go 400. Okay, it looks like I need to go farther right. Right is that one. I'll go 20. Very close. I think I'll go 40 now. And I'm going to go a little higher to make sure I can get that vertex. A little higher than 400. I'm going to go 500. I'm going to go 500. Okay, feel satisfied. Now I can use my second calc maximum. Second calc maximum. Oh yeah, left bound. Okay, here. Ignore the marker or whatever. Ignore the cursor I said before. Okay, here's the vertex right there. I went left of the purple dot, somewhere like over here, like -2 or something like that. -2. And somewhere over here. Now remember I went as far, I think it's 40, somewhere over here. So I'll do 30. Yeah, that's okay. I see the flag is on the right-hand side of the right bound of the dot. Hit enter. Okay, the calculator does this sometimes. It's trying to say 20. It's just not saying 20. It's trying to say 20. The vertex is 20, 400. The vertex here so this is your X. So there's your, okay, that's your X. Oh, X is the width. This is 20. So this is 20. The 400 is the area. See, the 400 is from this graph. 400 is the area. This is 400 squared units. So the Y, over here. If X is, what was that, 20? Y's got to be 20. Well, look at that. Turns out the rectangles is a special one. It's called a square. To get the maximum area, you want to use the fencing, so you build a square, not a rectangle. Okay, this is true. A square is a rectangle, but a rectangle is not a square. I'll say it one more time because it sounds weird. A square, by definition, is a rectangle. What's the definition of a rectangle? Opposite sides are congruent. That's your geometry. So the sides don't have to be the same length, but they could. What's the definition of a square? Oh, opposite sides are exactly the same. All the sides are the same. Well, see, a rectangle is not a square, but the square is a rectangle. So your dimensions, what's the dimensions right here? You need a 20 yard by 20 yard area. And the maximum area would be 400 square yards. And you're going to get a couple of those. I selected those for you out of your textbook. My power plug. My computer is going to die otherwise. Okay, there it goes. All right, Bonnie, I've left 3. I'm going to let you kind of mess around with those if they ask for it. Because of time. I'm leaving 3 of those. And let me stop this screen. So if you want to work on those, or if they don't care after class, then whatever they want to work on is fine. Of course, fine with me. Okay, so remember the little baby quiz? Oh, I need to activate it first. I need to activate that. Yeah, Math 25. Number 5. Okay, I just published it. Let's see, there it is. I just published it. You guys let me know if you see it. Thumbs up or whatever, shake your head up and down. It's daily quiz number 5. Okay, Farbod got it. Anybody else? Okay, Selena, I see it. Okay, so I'm going to put you in group quiz. It's all about 2.1. I just checked it too. There's 5 problems. It's about imaginary numbers. So just like in the past, you're going to put your answers in. Each of you, you don't have to copy the other person. If you disagree with an answer, you could put in whatever you want. It doesn't have to be a group answer. It could be whatever you want. All right, let's see if I can find breakout rooms. People are here. So 3 or 4 people again in a breakout room. Let's see, Bonnie's in one of these. Bonnie's not in a group of 3. Yeah, no, you're not. Okay, so after you're done with this, if you want to come see me for any particular question, I'll be around until 10:30. I have a 10:30 class. Otherwise, Bonnie will be available. Okay. Otherwise, see you Thursday. So Bonnie, let me stop the recording here.